Hi, welcome back. So what I'm going to do in this video is I'm actually going to do an example calculation using significant figures, and I recommend, I guess maybe a good idea of what to do with this is maybe to just maybe watch one of these examples. I'll maybe do, I don't know, 5 of them. Maybe watch one of them and make sure that you sort of understand the concept. And then really once you feel confident, I'd say you're probably fine to move on to the next concept. But if you want to, if you feel you need more examples of significant figures, the point of this is so that I'll hopefully make more examples than you would need. So if you happen to need a whole bunch of examples, a whole bunch of examples will be here for you to watch. So anyway, let's do a problem. And we're going to do a problem that's going to be all multiplication. So let's say we've got 1.54 times 0.094060. And then I'm just going to arbitrarily change colors, times 3.2, then let's say times 0.00. I've heard that you're always supposed to make sure you have this leading 0 in there, so I'll just put that in. We'll say times 0.00036. So now the question is, and let's actually just go ahead and do this calculation right now. I'll get the calculator out. And one of the things I do want to make sure that you understand is that I should not, and hopefully I've driven the point home enough by now, but I should not round after each operation. So like if I did 1.54 and then multiplied that by 0.09406, I wouldn't round at this stage, right? Because I've got 2 more calculations. I've got 2 more entries to put in here. So if I round at this stage, I run the risk of getting the wrong answer. So that's why it's important, and you haven't necessarily seen this yet, but it's important to have like a long string of calculations. So, this whole thing is a long string of calculations. Because it's nice to have this so that I can just throw all of this into a calculator. It's not like I compute, it's not like I just compute this part right here and then, I write it down. I think it was 0.14. And if I rounded, it would have been 0.145. And then this is what, if had I rounded, I would have thrown that into the expression here. But that's not what we want to do. So I'm actually going to go ahead and erase all of that. But anyway, actually I'll erase that too. So anyway, I'm going to go back and get the calculator out. Let's start from the beginning. We've got 1.54 times 0.09406 times 3.2 times 0.00036. Okay, and let's actually, I'm just going to write down, I'm going to copy this down. So we've got 3 leading zeros, 0.000. So we've got 0.000, I think it was 166 something. So 1668699. Let's write that down. 1668699. And I've been making a bunch of copying mistakes, so let me just double check that. 00016686699. Okay, and so this is what the calculator spit out. So I'll write this down. This is what calc got. And so now we have to figure out how many significant figures to report this to. And remember, we've got all multiplication. And even if we had a division in here, we could use this rule too. But the nice thing about when we've got just this long string of multiplication, all we have to do is find the least number of significant figures. And since we're just kind of learning significant figures right now, it might be a good exercise to just count how many significant figures we have in each of these numbers. So how many is in this first number? Well, all of these digits are significant, right? So we've got 1, 2, 3. We've got 3 sig figs. How about in this second number? Well, both our leading zeros, both of these leading zeros are not significant, right? But then every other digit, so 9, 4, 0, 6, including this 0 right here, right? Including this 0 to the right of the decimal point, or I guess if we're finishing off with a 0, that's like saying that's another little piece of information that we can consider significant about this figure, right? So we are going to have 1, 2, 3, 4, 5. We're going to have 5 significant figures. But then how about this number? Well, both of these digits are significant, right? But we only have 2 of them. So we're only going to have 2 sig figs here. And then finally this one. We've got all these leading zeros. So we've got 4 not significant figures, which we don't really have to keep track of so well, but we've got 4 non-significant figures. And then we've also got 2 significant figures. So how many sig figs do we report this number to? Well, we've got 2, right? And we've actually got 2 twice. That's the least number of significant figures that we have. So what we are going to say is that this is going to be written as 0.00017. This number to the right of the least significant figure was a 5 or higher, so we're going to round up. And how about if we wrote this in scientific notation? So we got the really nice way of dealing with, we've got, enough zeros to write in scientific notation, and scientific notation also gives us a great way of keeping track of how many sig figs we have. So we would count how many decimal places we want to move this point. So we would count 1, 2, 3, 4. We want to move the decimal place 4 decimal points back. So we're going to write this as 1.7 times 10 to the minus 4. And that would be our final answer, even though this one would be fine too. Good rule of thumb is you can almost, I shouldn't say you can never get in trouble for this, but I can say with relative confidence, regardless of where you're taking chemistry, that you can almost never get in trouble for using scientific notation. So this is the answer I would write down, 1.7 times 10 to the minus 4. Anyway, hopefully you found that helpful. In the next couple of videos, I'll just do a couple more examples. Should you need them, if you feel that you get this well enough, then I'd say just go ahead and move on to you can skip the examples and move on to the next concept. So anyway, thanks for watching, and I'll see you in a future video.